Kubernetes cluster is made up of several components that work together to manage, orchestrate, and maintain containerized applications across different environments. Here's a detailed explanation of each component from the mind map, categorized under control plane, nodes, and add-ons. 1. Control plane. The control plane is the brain of the Kubernetes cluster, responsible for making global decisions about the cluster, like scheduling, detecting and responding to cluster events, such as starting a new pod when a deployment's replicas field is unsatisfied, and managing the overall cluster state. API server. The API server serves as the central management hub for the cluster. It exposes the Kubernetes API, which is used for communication with the components of the control plane, other system components, and user commands. It processes REST requests, validates them, and enforces rules before allowing changes to the system's state. Scheduler. The scheduler watches for newly created pods that have no assigned node, and it selects a suitable node for them based on available resources, policies, and constraints. Its main job is to ensure optimal resource utilization across the cluster. Controller manager. The controller manager runs various controllers, each responsible for maintaining the desired state of the cluster. For instance, the replica set controller ensures the number of pod replicas matches the specified number, and the node controller monitors the health of nodes. etcd is a distributed key value store that serves as Kubernetes backing store for all cluster data. It stores the configuration data, the state of the cluster, and any other data that needs to be shared across the system. It plays a crucial role in ensuring consistency and reliability. 2. Nodes are the worker machines in the Kubernetes cluster where the containerized applications run. A node can be either a physical machine or a virtual machine and contains the necessary services to run the containers. Kubelet. Kubelet is an agent that runs on each node in the cluster. It ensures that containers described in pod specs are running and healthy on the node. It communicates with the API server to receive workload instructions and maintains the state of the node. Kube-Proxy. Kube-Proxy manages network rules on each node. It helps with network communication within the cluster by routing traffic to appropriate pods and services. It can manage the service's virtual IPs and port forwarding to provide network connectivity. Container Runtime. This is the software that is used to run containers. Kubernetes supports various container runtimes such as Docker, Containered, and CRIO. The container runtime pulls container images and runs the containers as directed by Kubelet. 3. Add-ons. Add-ons are optional but useful extensions to a Kubernetes cluster, providing additional features and functionalities that help manage, monitor, and interact with the cluster. DNS. Kubernetes includes a cluster DNS service that assigns DNS names to services within the cluster, allowing components to communicate using service names instead of IP addresses. This service is critical for service discovery within the cluster. Dashboard. The Kubernetes dashboard is a web-based interface that provides a visual representation of the cluster. It allows users to manage and troubleshoot workloads, view cluster resources, and access logs. Monitoring tools like Prometheus or Grafana are often deployed as add-ons to collect metrics from the cluster. These metrics help in observing cluster performance, setting up alerts, and ensuring the system is operating efficiently. Logging. Centralized logging solutions collect logs from the various components, nodes, pods, etc. of the cluster. This makes it easier to troubleshoot issues and maintain a history of system events. Tools like FluentD and Elasticsearch are commonly used for logging in Kubernetes. How these components work together. The control plane components manage the overall state and functionality of the cluster. The nodes execute the workloads, while add-ons extend and improve cluster capabilities. For instance, the scheduler assigns workloads to nodes, while the